Hey everyone, today we are doing chapter 8. So this is our first real big step into inferential statistics where we use a sample number to infer something about the population. So as you can see, 8.1 is called estimating a population mean. At this point, if we were to estimate the population mean, the best we could do is we take a sample, ideally a representative sample, and that sample mean X bar would be our best guess for what the population mean mu is. So they talk here about a definition of a point estimate. A point estimate of a parameter is the value of a statistic used to estimate the parameter. Very wordy there in terms of these words, but notice, remember, parameter just means a number from the population, and statistics just means a number from the sample. So we're saying a point estimate to estimate a population number is just the value of the sample number that we use to estimate that population number. So in other words, or for example, I should say, X bar is a point estimate for mu. So the sample means a point estimate for the population mean. S, the sample standard deviation, is a point estimate for sigma. So of course up here we had the mean, down here we have the standard deviation. These are the only two that we've seen so far. There's others, we'll see other ones later, but those are the only 2 point estimates we have. But notice a point estimate is a single value. Well, we have something called sampling error. Remember we talked about that in an earlier chapter. Sampling error is how far the sample mean in this case would be from the population mean. So sampling error is just how much error we have using one of these sample numbers, a statistic, to estimate a population number, the parameter. So we know that we will often, usually in fact, have some sampling error between the sample number and the population number. So what we do is we build something called a confidence interval. And then a confidence interval will use a point estimate to form an interval where we, let's say it this way, are pretty sure. It's not very mathematical, is it? The population number is in there. Let's look definitionally what we're talking about there. So let's go here. We've got this thing called a confidence interval estimate. A confidence interval, CI, will abbreviate it often, an interval of numbers obtained from a point estimate of a parameter. And then the confidence level is the confidence we have that the parameter lies in the confidence interval. And then the confidence interval estimate is the confidence level and confidence interval both together. So let's give an example so that we can translate this more into English. So for example, say that I've got a number for X bar and say it's 50. And let's go further to say that we are 95% sure that mu, the population mean, is within 2 of X bar. Well, that 2 that within is called the margin of error. Thus, the margin of error E equals 2. So we've got this thing called the margin of error, and it just represents how close we think X bar is from mu in this case. And so here we're saying, hey, I think the margin of error is 2. I think our sampling error is no more than 2. Are you sure of that? Well, I'm 95% sure. We can't be 100% sure unless we have the entire population. So that's why we have this confidence level. The 95% is the confidence level in this case. So that's where we go from here. So let's build that. Here's what we do. We take this X bar and then we add or subtract the margin of error to figure out what my actual confidence interval is. So I would say we go X bar minus E to X bar plus E. To undo that, that was a little unfortunate. X bar plus E. And so in our case, well, this would have been the 50 plus or minus 2. So I go 50 minus 2 to 50 plus 2. That's going to be my confidence interval. And so we think the actual value of mu, the population mean, is somewhere between 48 and 52. Are we sure it's in there? Well, I'm 95% sure it's in there. And so we would word it something like this. We can be 95% confident that the population mean mu is between 48 and 52. That's the idea. That's how we word it. That's how we do our confidence intervals. Now, let's go from there. There is something I want to show in this that we're going to use a little bit later. Notice 4% confidence that the population means in there. That means there's a 5% chance it's not. Note, if we are 95% confident mu is in the confidence interval, CI, there's a 5% chance, the rest of the 95 to get up to 100, we are incorrect. This 5% is called alpha. The symbol looks like a little fish, but that's the letter alpha. And in this case, we would say alpha is, we usually write it as a proportion, 0.05. So that proportion is the chance that we're wrong. We make this statement about the population mean, well, there's a 5% chance really not in that interval, but we're 95% sure it is. So we have a high probability or high confidence that it is. Okay, so that's the idea of section 8.1. Let's jump into 8.2 and we'll actually do a problem. All right, 8.2, confidence intervals for one population mean when sigma is known. What is sigma? Recall, sigma equals the population mean. Standard deviation. So we're assuming in these problems in this section that we know what the population standard deviation is. Now, what we're going to do is we're going to build these. We're going to find what's called a Z interval, confidence interval. And so we're using Z, remember those populations, those areas under the Z curve that led to the proportion of the chance that we think we're right. So we're using that idea. So there are some assumptions, some things that have to be true in order for us to be able to find this Z interval. And the assumptions, there's 3 of them. The first one, it has to be a simple random sample. SRS. Why does it have to be a simple random sample? Remember, that's the best way that we can assure with the highest level of confidence that the sample will be representative of the population. So we want it to be a simple random sample. The second one, and hopefully this doesn't surprise you, the population has to be normally distributed. Because since we're using that Z, it's based on the normal distribution. So population is normally distributed. And what did we find out earlier? That if the population is not normally distributed, or if I don't know if it is, or we have a large sample. What makes it a large sample in this case? Well, remember we said if the sample size N is at least 30, so greater than or equal to 30, it's a large sample. Even if the population of the variable is not normally distributed, the population of all samples of size 30 or larger is normally distributed, so we can still use that Z. And then lastly, sigma is known. So we do know the population standard deviation. All right, so those are the three assumptions that we need to have. So what we're going to do is let's jump in and actually just do a problem out of the homework. So I'm going to jump in, I'm going to grab problem number 5 out of the homework, and I already pulled it up, but it's right here. Okay, so problem number 5, it says for the provided sample mean, sample size, and population standard deviation, complete parts A through C below. So they give us X bars 28. Remember, that would be my point estimate. In other words, my single number that's my best estimate of the population mean. They give me the sample size 36, and they tell me sigma is 3. Well, they don't tell us here that it's a simple random sample. We're going to assume that it is. They don't tell us it's a normally distributed population, but it doesn't matter because the sample size 36 is 30 or bigger, so we're okay. And then we know sigma, the population standard deviation is 3. The question says find a 95% confidence interval for the population mean. Remember, we're trying to use that sample mean to estimate what the population mean is. So we're going to build a confidence interval around the sample mean. Well, we have technology. We have StatCrunch. StatCrunch is going to do this for us. So that I don't have to memorize these numbers, what I'm going to do is I'm just going to grab my phone. I'm going to take a quick picture, and I'll get those values of X bar, N, and sigma. And I'm going to go over here to question help. I want to open up StatCrunch. Sometimes it opens right up. Sometimes it makes us do a login type of thing. Luckily, this time it looks like it's going to open right up for us. Okay, so we've got StatCrunch. What I do is I come up here to stat, but remember I'm doing a Z confidence interval. So to go to Z stats, I only have one sample, so I go to one sample, and then I have the summary. I don't have the data. I don't have the individual data values, but it had calculated for me what's X bar, what's my sample size. So I say with summary. And then I go in and I just type in what they gave us. So we had a sample size of, we had an X bar sample mean, of 28. Our standard deviation, they said, was 3, and the sample size was 36. Notice perform what? Well, it's checked off to be a hypothesis test. That's what we're going to be doing next in a later chapter. Right now we're doing confidence intervals. So we click on confidence interval. They did ask for a 95% confidence interval. So we just change that to the decimal of 95%, 0.95, and hit compute, and that's all we do. It does the calculations for us. That lower limit and upper limit, those are the boundaries of my confidence interval. So again, I just took a quick picture of those because now what I'm going to do is I'm going to go back and enter them into my problem. So let's click down here. Let's go back to the homework problem. It's right there. And it says the confidence interval. I'm just typing in the lower limit as the left side. It says round to 2 decimal places. 27.02 is what I have. I'll tab over. The upper limit is 28.979, so I have to round up to 28.98. And we got it. All right. Identify and interpret the margin of error. Well, let's talk about this, because remember what we did. We built this up. We said essentially, let me see if I can find my pen. We said this, we took X bar plus or minus our margin of error. Well, so that was X bar minus the margin of error to X bar plus the margin of error. Graphically, it looks like this. X bar is right in the middle. Over here on my confidence interval is X bar minus the margin of error. Over here is X bar plus the margin of error. Those are supposed to be parentheses, not arrows. But so I go the margin of error this way, that's E. I go the margin of error this way, that's E. So in total, I have 2E. So that distance between the endpoints is 2 margin of errors. So half of that distance is the margin of error. So the margin of error is half the confidence interval. That distance. So what I'm going to do is I'm just going to subtract the number. So looking back, 28.98, that's the right side, minus the left side, 27.02. That's going to give me the length of the confidence interval. I'm going to divide it by 2. It's going to give me the margin of error. So I pull out my calculator, 28.98 minus 27.02. We could have probably done that in our head, 1.96. That's the length of the confidence interval. I divide it by 2, and I get 0.98. That's my margin of error. That's what I'm going to put in for the margin of error. Well, let's go do that. 0.98. All right, so I got that one right. So now let's go interpret what this says. Let's see, there's another part remaining. We don't know if I need any of this, so let's just read through. We can be 95% confident that any possible sample mean is within the margin of error of 28. Well, remember what we're trying to do is we're trying to find out where the population mean is, not the sample mean, so it's not A. B, we can be 95% confident that any possible value of the variable is within the margin of error. So what they're saying is whatever the data was I collected, every data point is no. Again, we're trying to identify where the population mean is. We can be 95% confident that any possible value of the variable is within the margin of error of the sample mean 28. No. We can be 95% confident that the population mean mu is within the margin of error of the sample mean 28. That's exactly it. What we're saying is we can be 95% confident that the population mu is within 0.98 of 28. Might be below, might be above. That's what values of our endpoints. And then lastly, expressed as a decimal. I'm glad I didn't erase all that, because express the endpoints of the confidence interval in terms of the point estimate and the margin of error. Well, what they're talking about here is, look right here. That's what they're doing, that plus or minus. So we're just going to fill that in. Oh, X bar, we said was 28. Plus or minus my margin of error was 0.98. Well, that's what I'm going to put in. We'll put a 0 so that we see that's a decimal. That's what I'm going to put in here, is the way that confidence interval was created was starting with the sample mean, that point estimate, 28, and then plus or minus point. All right, so that's the end of that problem. I like that problem real well because it really, I think, does a good job of explaining the whole idea of what a confidence interval is and how to find it. So from there, let's clear all this. We're going to jump back in and go back into the notes, and I'm going to go into the next section. So let's go into 8.3. Notice it says confidence intervals for one population mean when sigma is unknown. So the difference here is we don't know the population standard deviation sigma. So what we have, we don't know population standard deviation sigma. We estimate sigma using the sample standard deviation. Remember, we called that S. Then, now what happens is, since we're estimating the population standard deviation, we don't have it. We can't use that Z curve. We have to use a different curve called the T curve. And we find what's called a T interval. So for our purposes, all we have to do instead of doing Z statistics is we click on what's called T statistics. And so here's the big key. If we know the population standard deviation sigma, use Z. If we don't know the population standard deviation sigma, use T. That's the big takeaway here. That's the only difference for us as far as when we compute it. There's a T chart where we have a different table to find T values. So if we're using the tables, we'd have to use a completely different table. It's set up a little bit differently than the Z table, but we're not using any of those. What we're doing is we're using StatCrunch. So we just have to say, hey, do a T interval instead of a Z interval. Okay, so that's what we have. We're just gonna go, I'm gonna show you how close this is to what we just did. So let's go pick out another problem. Oh, let's state this. Let's state the assumptions again, because we need to make sure that we know what has to be true in order for us to do this problem. So what we're going to do, let's list the assumptions. They will look familiar. The first one, it has to be a simple random sample. All right, that seems reasonable. 2, it has to be a normal population. Or N has to be at least 30. So just like the last one. And then the third one, remember the third one for the Z intervals, we know sigma. Well, this is just, we don't know sigma. So very similar to what we had before. But now let's go and we're going to do a problem out of the homework. We're actually going to jump in and just do problem 17. So we're still here in the homework. They were all excited. Here we were done. Let's pull up problem 17. See what it looks like. There it is. Okay. Suppose that the average time spent per day with digital media several years ago was 3 hours and 44 minutes. For last year, a random sample of 20 adults in a certain region spent the number of hours per day with digital media given in the accompanying table. Preliminary data analyses indicate that the T interval procedure can reasonably be applied. So that means that whatever they looked at, it satisfied those 3 assumptions we just listed. Find and interpret a 95% confidence interval for last year's mean time spent per day with digital media by adults in the region. Now they tell us what X bar is and what S is. They've calculated it, but we're not going to use those because they actually give us the data. And I want to show you how to use the data in StatCrunch to go ahead and find one of these confidence intervals. Notice also here they talk about click here to view page 1 of the T table, click here to view page 2 of the T table. We don't use the Z table or the T table at all. So clicking there is not going to do anything except confuse you. But we do want to see the data. So we'll click here. Here's the data. It's going to load it up. All I'm going to do is I'm going to open the data in StatCrunch. Okay, so there's all my data. So what I'm going to do is I'm going to go back to stat, but instead of Z stats, because I don't have the population standard deviation sigma, I go to T stats. Now, notice what's going to happen, and I'm going to go one sample, but this time I have the data, so I'm going to click with data, but notice I didn't plug in the sample standard deviation. I don't have to because I have the data. The computer's going to calculate the sample standard deviation for me. So I come up here. I'm going to select variable 1. That's where my data is. Again, it's not a hypothesis test, it's a confidence interval. 0.95 is correct, that's what they asked us for. And then I compute. Simple as that. Again, I'm going to take a quick picture, find my lower limit and my upper limit. All right, got that picture. Let's go back and put in our answer. So it's very quick to do. The big thing is we have to know, we have to recognize, oh, I don't have the population standard deviation. I have to use T instead of Z. It gives me a slightly different number for my confidence interval. We can go and close that down. It's going to give us a slightly different numbers for my confidence interval, but if you put in the Z values, you just get it completely wrong. So the 95% confidence interval to 2 decimal places, I had 4.077, so 4.08. And the other side was 6.142, so I just leave it at 6.14. And we got it. So easy as that. Now they say interpret, select all that apply. Well, remember, here's how we interpret. Let's jot this down so that we kind of remember what's happening before we look at the answers. We would say something along the lines of, we can be 95% confident that the population mean mu, and we may even be more specific here because we know what the mean stands for. So we could say something like the number of hours on digital media. But remember, it's the mean number of hours on digital media. The population mean number of hours on digital media is between 4.08 and 6.14 hours. So that's the type of thing we're going to word. That's how we're going to word it. So let's look. There's a 95% chance that the mean amount of time spent per day on digital media last year by all adults in the region between the intervals bounds. With 95% confidence, well, that sounded good, the mean amount of time spent per day on digital media last year by all adults in the region is between the intervals bounds. That's what we're looking for. 95% of all adults in the region. No, it's not 95% of the people. It's we're 95% sure that's where the average is. And 95% of all possible random samples of 20 adults, we don't know how many percent of the samples will be in there. We just know that we're 95% sure that that's where the mean is. I will be perfectly honest with you. When I read A, there's a 95% chance that the mean amount of time spent per day on digital media last year by all adults in the regions between the intervals bounds. I don't see a big difference between A and B. I will tell you, however, I do know that when we word it, we should be saying that we're 95% confident. So I'm going with B, and we'll check our answer. So B is right. So that's my hint to you. The author, especially in this book, like to word it, hey, with 95% confidence, blah, blah, blah. So that is the standard way of wording it. That's typically what they're going to use there. So the good news is that's the end of these 3 sections, which is the end of the entire chapter. So practice this stuff, a lot of new stuff in statistics. So you just have to kind of stick with it and work through it and get the understanding. But if you understand what's happening instead of just trying to memorize it, you'll do much better. So don't get discouraged if some of this seems a little bit complicated, but just keep working at it. And remember, you can do this.